Hi everyone, my name is Mikio. In this video, I'll explain how to use Pytest fixtures. So what are Pytest fixtures? Pytest fixtures are basically functions that you can use to initialize your test environment. They can provide consistent test data or set up the initial state of the environment. When you use Pytest, you can create a function that provides the dependency and mark it as a fixture using pytest.fixture decorator. Then, test cases can use it within the test function, and it is easy to share fixtures across test cases in different files. Also, it is easy to add steps to clean up the resources. Let's look at the details. Let's use a simple example of a Python class customer like this. This class has two properties, cast ID and label, which can be accessed using the getter methods cast_ID and label. It also has two methods, level up and level down, to increase and decrease the level value by 1. But when decreasing the level, the value should not go below 0. The initializer takes parameters for cast_ID and label, and the default value of label is set to 0 if it's not specified. Then let's first look at an example without fixtures. We can create simple test cases to test this class like this. Then, when you run Pytest command, the test should pass. But looking at these test cases, you might notice that each test case creates a new customer object. In this example, we need only one line to create an object, but it can be more complex, and it will be inefficient to repeat the same steps in each test case. Let's make it more efficient by using a fixture. You can create a fixture by defining a function in the following 3 steps. First, import Pytest. Then, create a function with the pytest.fixture decorator. Finally, specify the fixture name as an argument in the test functions. In this case, customer is the fixture name, so you can specify customer as an argument of the test function. Then, the fixture becomes available within the test function. Now, the entire test file looks like this. The fixture is created here, and the test functions request the fixture by specifying it in the arguments. The second test function is not requesting the fixture because the object is initialized differently. But still, we have managed to eliminate the object initialization from the other test functions. The tests should still pass. So we eliminated some repetitions in the test functions by using a fixture. But if the fixture stays in the same test file, you might not think that it's very useful. You might think that it can be just a normal function. But one of the advantages of using fixtures is that they can be shared across multiple test files in the same directory or subdirectories. All you need to do is to define fixtures in a file called conftest.py. Let's create the file conftest.py in the current directory and move the fixture from the test file to this conftest.py file. And be sure to import the class and Pytest as well. And now the test file looks like this. When the fixture is not defined in the same test file, Pytest automatically looks for conf.test.py file and find it in this file. So the test should still pass. If you had other test files in the same directory, the fixture would automatically become available in these files as well. Each fixture has a scope. The default scope is function, meaning that fixtures are initialized when requested in the test function and destroyed when the test function finishes. It is the same behavior as our first test file, where each function creates a customer object. Let's verify the scope by looking at the object ID. Here, I've added a print statement to each test function. Then run Pytest with the -rp option, which shows the output of print statements in the summary info section. As you can see, the object ID is different in each test function, which means each object is different. You can use other scopes such as session. The session scope means that fixtures are initialized when they are first requested in the test session. Then Pytest uses the same object during the test session and destroys it when the test session ends. Let's change the scope to session. You can change the scope by adding parameter scope to the pytest.fixture decorator, like this. Now let's run the test again. In this case, the fourth test function fails. It's because the customer object is now shared across the test functions. When the third function runs, the level value of the customer object is increased, so the customer object in the fourth test function does not have the default level value. We should probably update the test function like this. Now, in each test function, we keep the original level value and compare it with the new value in the assert statements. Now, when I run the test again, all tests pass. We've been using a fixture, but it is a bit limited because the object has a fixed cast ID and the default level value. It would be more useful if we could create an object using different parameter values. So instead of creating an object with fixed parameter values, like the one on the left, you can create a fixture that returns a function to create an object so that you can specify the parameter values as an argument in the function. So this is sometimes called a factory pattern in object-oriented programming. So let's create a new fixture in conf.test.py and call it customer factory, like this. In the function customer_factory, another inner function _customer is defined. The inner function uses two argument values, cast ID and level, to create a customer object and returns it. So when this fixture is requested, the test function does not receive a customer object, but receives this inner function instead. So it can create a customer object with any parameter values. Let's use this fixture in the test file. In the second function, you can specify the new fixture as an argument and use it to create a customer object. In this case, the change is minimal, but if the initialization step were more complex, it would significantly simplify the test function. So when I run the test should still pass. Fixtures can use another fixture. So in this example, we can use the new fixture in the first fixture like this. fixture customer uses the new fixture, customer factory, to create a customer object. In this case, the test still passes. When using external resources in tests, it is essential to clean up when the test finishes, which is sometimes called teardown. For example, if you open a file during the test, you should close the file when the test finishes. If you connect to a database, you should disconnect from the database, and so on. In Pytest, it is easy to implement teardown logic when using fixtures. The fixture on the left is the one we've been using so far. To add teardown steps, instead of using return, we can use yield to return the object after creating it. When the test function finishes using the fixture, the code after yield runs, so you can write cleanup logic here. There's nothing to clean up in the example, so let's add print statements for demonstration purposes. In conftest.py, update the function customer_factory and add two print statements, one before the inner function and the other at the end, and change the return to yield, like this. So when running Pytest, you can see that messages at the session beginning and end. When setup and teardown run depends on the scope of the fixture. So let's change the scope to function. And then run the test again. Now you can see that the setup and teardown messages before and after each test function. In this video, I've explained how to use Pytest fixtures to initialize your test environment. We first looked at how to create a Pytest fixture. You can create a fixture by creating a function with the pytest.fixture decorator. You can use the same fixture in multiple test files if you define them in the file called conftest.py. You can also control the scope of fixtures by adding the scope argument. We then looked at how to add function arguments to fixtures by using the factory pattern. Finally, we learned that adding teardown logic to fixtures is easy, which helps automate cleaning up the test environment. Fixtures in Pytest is very powerful, and it is critical to understand how to use them if you want to run tests efficiently. The functionality I've just explained in this video should be enough to get you started, but you can find more information on the Pytest website. That's it for this video. I'm Mikio, and thank you for watching.